Welcome, everyone, and thank you for joining us for today's webinar, When to Use GraphRAG, AI Use Cases that Benefit from Connected Data. My name is Amanda, and I'm part of the virtual events team here at Neo4j. I'm thrilled to be joined by Zach Blumenfeld, AI ML Product Specialist. We are super excited to have you all with us today. Just a quick note about questions before we get started. We invite you to submit any questions you have throughout the session using the Questions tab located at the top of your screen. We'll answer as many questions as possible at the end of today's presentation. And if we don't get to them all, someone on the Neo4j team will reach out to you directly, or you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. So with that, I'll go ahead and hand it over to Zach.
Awesome. I'm so happy to get everything started with everyone. So this is going to be a presentation about GraphRAG. So GraphRAG is a term that is getting a lot of buzz right now. We're hearing more and more about it inside of AI circles. And while we're hearing more about it, I thought it would be appropriate to take some time to talk about how we really think about and define GraphRAG and where it makes sense to think about using GraphRAG. So the way I've structured our agenda for today, we have a lot to go over. But we're going to start out just defining what GraphRAG is and some of the patterns involved in using GraphRAG, talk about the advantages in the use cases, and then getting data ready and going through some GraphRAG examples. So 3 and 4, if we have time, I'd like to walk through a demo with everyone. And we'll end with some resources and Q&A and additional information. All right, so let's just get started with what is GraphRAG. So it's actually quite broad from our perspective. This is a diagram of just ordinary RAG, right? Retrieval augmented generation. And as we may already know, in RAG, what happens is instead of a user prompt or question going directly to a language model to complete a response, we put this retriever component in the middle, and that retriever component will go and pull relevant context from some external, usually proprietary data set, and it will use that to augment the prompt to the language model to give you a more complete and accurate answer. So you can imagine with use cases like, for example, if you had an enterprise that needed to access medical records to answer analysis on those, or maybe there was an analysis on supply chain data or questions about customers, all of that's proprietary data. And really to answer that appropriately, the language model doesn't have that in its training data, obviously. It's going to need to access it from somewhere. And so this is really where RAG becomes valuable. All GraphRAG is just putting a knowledge graph somewhere in that process, either to be that external proprietary data set or to be a mapping layer to that external proprietary data set. And it really provides a powerful retrieval mechanism by offering a lot more rich context with that graph structure. And so let's just talk about a graph data model for a second so we can lay the groundwork there, and hopefully this point comes across a little clearer. But the reason this provides more context is because within a graph data model, and there's a few ways that you can model a graph, but I'll go over how we think about it at Neo4j. There's 3 primary components. You have entities, people, places, and things, which we think of as nodes. And then we also have associations or interactions between those people, places, and things, which we think of like relationships. So for example, in this diagram, a person can drive or a person can own a car. And then we have properties, which can go on either relationships or nodes. And these can be strings, they can be vectors for things like vector search, they can be arrays of things, they can be numbers and dates, all sorts of stuff. And the idea is with this structure, as we keep adding data and connecting data inside of it, you get this large collection of connected data. So all of these nodes and relationships, right, sort of grow, and it becomes this very sort of well-connected web of context, if you will. And so when we think about GraphRAG for accessing graphs, there's a ton of different patterns that we can talk about. And I don't have time to go through all of the patterns in a 30-minute webinar. But what I can do here is just go through some of the high-level groups. And what I'll mention actually before I even jump through all of those is there's a website called GraphRAG.com. It's just that. It's just the word GraphRAG.com. And if you go there, you'll find much more extensive links and documentations around these patterns. So I'm going to go over this very, very quickly. And then if you go there, you'll be able to find out much more info if you wanted to dive deeper into technical depth. But I'm going to categorize GraphRAG patterns as we currently think about them into 5 different areas. So there's what I'd call vector and hybrid search, which is basic vector and full text search that you might be familiar with from a standard RAG paradigm. But there's also things where you can do a vector search and then enhance that with a graph traversal and grab more information from a graph. So for example, a node might have a vector property, and then you can hit that and traverse out the graph to grab more information. And you can also use the graph to do different types of metadata filtering, which can be very valuable in certain scenarios, especially when you need to filter on data that's not necessarily in a document, but maybe entities connected to that document. We also have just deterministic query templates. So oftentimes you might know the logic that should be accessed, and maybe a tool inside of an agent. So for example, as we might see in our demo, a tool to be able to pull suppliers for certain products or to pull products that were provided by certain suppliers. So you can create templates that tools can use to then go and query a graph. There's also query generation, which is when we either prompt the language model to create an entire query by itself in a very free-form way, or we tell it to use different components, basically like different snippets of a query language. For us, it would be Cypher for a Neo4j database, and put those together in some way to construct them, which would be called dynamic cipher generation. There's also graph enrichment. So you might be familiar with like global community summaries and things of that nature. That would fall under graph enrichment. We can also use things like PageRank for Google-like search through a graph, Google-like retrieval, and also create our own types of graph embeddings, which I've gone over in a number of previous webinars and demos. And then the last one that I think about is query optimized graphs. Basically, when you construct a graph, for example, if you have a document that is hierarchically structured, you can replicate that structure in a graph. And that allows you to do like parent-child retrieval. When you sort of find documents that are at the bottom and move up, you can create hypothetical questions and then have answers for them. A bunch of fun stuff there. So again, I'm not going over this so that you can get like a full in-depth dive of all of these, just giving you the idea of sort of the breadth of what's involved when we talk about GraphRAG and all the different types of things you can do. And so now I want to talk about, so we've talked about what GraphRAG is, and now I want to talk about why it's valuable and some of the use cases that we see around it and when to use it really. And then after that, I'll show some technology and we'll get through after we get through some of these slides. So I want to take a step back and just think, what do AI and agentic systems need to really be successful? And to answer this question, I want to consider a use case for commercial contracts. And think about a use case where you have a law firm that has access to a lot of commercial contracts, and they want to improve their productivity by creating an agent that will help search through all those contracts and provide legal references and things given different types of questions that they have. So let's think about the types of questions that we can ask an AI agent given the type of data that it has structured to do retrieval on. So the first thing we can do if we have a bunch of commercial sort of legal contracts is you can think we can chunk them all up and we can throw them into something like a vector database or something, and we can put a vector index on them, right? And if we did that, we'll be able to ask some pretty neat questions like what contracts mention X, what contracts mention non-compete conditions, right? And you'll be able to pull some information back. But then what if you wanted to find very specific numbers of those things and say you want a little bit more of a detailed question where it's like find all non-compete clauses with no expiry date. And this type of question is implying that there's some entity or some concept of an entity called a clause, and that entity has a property called an expiry date, right? And so to answer this question in a consistent and accurate way, your agent or your AI system really needs to understand what the different entities are inside of your domain, right? So you really need some form of entity modeling. You need clauses, and maybe there's like organizations, and there's contracts and countries and parties and all this sort of stuff involved, right? So that's like the second step of things you need for like the next level of advanced type of question. And then when you get to sort of multi-hop questions and how things are related, like, so for example, in this third question, what organizations are incorporated in the United States and have these non-compete clauses, and who are the other parties involved? And for this type of question, the agent, to answer this consistently, actually has to have an understanding, right, of, okay, there's this concept of a country that has a contract, right? And that there's other parties involved inside of these clauses or contracts, right? And so for that, your agent needs to understand relationships. It needs to understand that organizations are party to clauses, and they're incorporated in different countries, right? And all these, different types of relationships in your data. And so this is what a graph basically gives you, right? And it's why a graph is so promising for supporting AI success and success with agents, is because not only does it give you this structure with the entities, the nodes, the relationships, and the properties, but it does it in a way that's simple and compact if you're using a property graph model. It's also very flexible. So if I wanted to add, maybe tomorrow, I'm like, I need a different type of entity, a different type of, organization or a location or something inside of my database, I can add that. And even though I have constraints so that my data is very organized and flexible, or organized and standardized, I still have the flexibility to add that. And also, when you use property graph models and graph databases, being able to traverse all of these in multiple steps becomes very high performance relative to other systems. So it's really that standardization, the organization, right? The flexibility that you get, which is especially important with AI, the number of queries that are going to be generated and written going into sort of the new AI age, right? As opposed to what we do now, where people spend time taking questions and writing queries about them, and being able to do that in a high performance way. And GraphRAG is really how GenAI accesses graphs, right? So think of GraphRAG as sort of the engine for accessing graphs, for doing this sort of stuff. And when we think about use cases, I'm very tempted to say that GraphRAG is great for, almost every sort of RAG use case. And while it's great for like the general, enterprise search, customer support type of stories, because generally they have a lot of mixed data, the way at Neo4j that we think about different sort of use case areas is really through this 7-graph model. So a lot of enterprises tend to have commonalities in the types of data that they have. Oftentimes they have multiple of these different categories of data. And this includes customer and product data. So think of things like retail or other types of electronics and products and things of that nature. You have suppliers, so like supply chain data, bill of materials data, that sort of stuff. Employee and HR data, both infrastructure and also electronic networks and security. Processes, so think of like manufacturing plants and stuff like that, or anywhere where there's sort of multi-stage processes involved. And transactional data, which I know transactional data is a very general term, but here we're referring to like banking and financial transactions. And what we find is that generally in places where a graph can help a use case are the same places where graph can help an AI use case. So if you have AI use cases for product recommendations, or for doing some sort of analysis on churn prediction, or creating ads, right? Those often tend to be very great use cases for GraphRAG. They fit under product and customer. And the reason is because for these types of use cases, they often involve requiring connecting and organizing complex data for AI access. So it's a lot of what we just went over, right? It's where, okay, I need structured data, maybe from some sort of system of record. If we go with recommendations, it's around customer transactions, but then I might also have product descriptions, I might have emails, I might have return orders, I might have all this other data. and I need to combine that together in some way. And my AI model or my agentic framework needs to understand how all of that works to answer these things accurately. Same with supplier data. If you want to use AI to help with things like inventory planning or doing SKU substitutions and things of that nature, we see use cases in network and security, everything from like infrastructure, grid management, and maintenance scheduling, to helping with security log summarization, anomaly and threat detection, helping people sort of in the employee place with career planning and management, understanding their org structure, different roles that are available, all this sorts of stuff. And just a couple examples of this that I'll walk through. These are Neo4j customers. And one such example is with a very large gaming company who is using GraphRAG to reduce time to insight for their analytics. So for this company, this is a situation where they have data that's spread across multiple sources. And you can think of it kind of like a combination of customer and product data, right? They have gaming and player data, but then they also have analyst reports, they have sales data, they have data around promotional campaigns and marketing stuff. And basically what they want to do is they want to allow their leadership team to be able to answer questions, for example, like how does a promotional campaign affect player engagement? Or how has a competitor launch affected our sales this last quarter, and should we do anything about it for next quarter's pricing strategy or something like that, right? And so traditionally, that would take a lot of work for an analyst to go through and translate that into queries and then query all these different systems and then put a report together and do all that sort of stuff. But what we see here is that effectively, by taking all of that data and creating this mapping layer inside of a knowledge graph, where you've been able to connect all these things together across promotions and revenue and player engagement and all of these different areas. When you expose that to an agentic system, it's able to find the right context that it needs of how all the data fits together and then query the data directly and pull that back, basically creating a lot of different reports much faster for analysts. And we see similar trends too with this consulting company called Data Squared, and they're dealing with similar analysts, kind of a similar scenario with different analysts, but a much different domain area. So they're dealing with intelligence and energy management, which again is going to combine operational records, financial data, and intelligence data. And again, combining all that unstructured and structured data together to get large reductions in analyst workloads. So what I want to do now in the short amount of time that we have, I think I have about 7 minutes to walk through this. I wanted to show you a very quick example, and I might expedite some of this just for timing reasons. But basically, I want to show you an example with customer data. And what this is, if I could probably just escape and go over here. So basically, what I'm going to do is I'm going to create an agentic system that's going to let me do some analysis on customer retail data. So this was originally from the H&M data set, but basically it combines structured data. So you'll see here like different articles that people can buy. You have customers that can buy those things. And then you have order details where customers are creating orders here and basically buying multiple articles within inside of those orders. But then as often is realistic, we also have, here we go. Well, we have also these return data. So basically there's going to be some instances where customers will return products. This was simulated. But basically, this is all unstructured data. So these are credit notes to customers that have returned products. And the idea is we want to take that data and we want to combine it together in such a way that we can ask questions about return data and also analyze our sort of structured retail data at the same time. And so what I've gone over here and done is I've created a schema that looks like this. And this schema has, as you can see here, it has customers creating orders. Maybe I can make that a little bit bigger. These orders have refunds, and those refunds also refund the article, but you can see the orders contain different articles. Articles are like pieces of clothing, and then product is like the main type. So think of it as like a product is a pair of jeans, and an article would be like a certain size and color of those jeans. And the articles have different suppliers in this scenario that supply those things. And then the products also have a different product type and a product category. And once we create a schema for this, the great thing is we can use that schema, and this schema also has annotations inside of it. So it has basically instructions for AI embedded inside of the schema. And I can use that to drive both my unstructured ingest and then also my structured ingest, which is really cool. So basically, while preparing all of this for GraphRAG, right, what I can do is I've had a file here, and I'm going to jump into code a little bit, but hopefully it'll be informative, where I'm using our GraphRAG Python package. And basically what I'm doing here is I'm getting the schema. I have it in this turtle format. It's just basically another file format that I've used and transformed it into the Aura importer, which you were just looking at. But basically, once I have that in there, I don't actually have to write too much code in here to basically call this knowledge graph builder pipeline to build the graph. And I've done it beforehand just because it takes a few minutes for that to run. But once it's run, basically I get a graph that looks kind of like this. And what I'm going to do here is change the order of these so you can see the, there we go. So you can see the colors a little bit better. But if I zoom in here, I've got my main document. This was the document we ingested, this gray node. And then that document was split into chunks. And each chunk had a certain amount of, you'll see here, these articles and these orders, and then the credit note. So you see durability concern raised by user after limited use. And so these are basically showing you the credit note, the order, and then the article. So we've ingested part of the data, right? This is the unstructured part. But then what we can do is we can go back to our importer, and I have my structured CSVs prepared here, and I can say run import. And what will happen is it will actually merge this data with the unstructured data that we were just looking at. It's the same exact schema. I've altered it only slightly. I've took some nodes out because I only want to ingest, right, these structured CSVs. And then once I've done that, if I go back here and I give it a second to reload, or maybe I'll just run it again so you can see. Now what you'll see is a much more complete graph. So when I go back in and look, or even if I just, for example, click in here, and I just picked any article, you'll see the articles now have these other properties that came from structured data. But if I clicked on an article, here would be a product, here would be the supplier data that was structured, right? And I could look at other things that that supplier supplied. So I get all of my structured and unstructured data in one place, which is really cool. Then once I'm done with that, I can take that same schema and I can start driving GraphRAG queries. So I'll try to do this quickly because time is always short. I feel like on these half an hour is so little time to walk through as much as I want to walk through. But basically what I've set up here is a small agentic application. And I've used semantic kernel for this. I've done another webinar where I've used semantic kernel in the past. But basically the way this works is I have something called a retail plugin. And that retail plugin has a ton of functions like search products, recommend products, do customer segmentation, get different aggregated statistics about products and suppliers, and then also answering general questions. And you can see these are annotated. And basically what it means is I'm annotating these functions, which are going to be handed over to an agent, and an agent can choose to use these functions in any order. These are actually implemented inside of this service object. And you'll see that it's basically a bunch of Cypher queries and also vector search. So we are using the GraphRAG package again here. We're using vector search, and we have product recommendations as well here. And you can see the great thing about a graph is that these, what would be like very large multi-op queries if you were dealing with a SQL database, even though it looks kind of ugly, basically when I'm doing a recommendation, I'm taking customers and I'm looking at what similar customers bought, right, based on like shared purchase history. That runs very quickly. Same thing if I look at some of these other queries, for example, like getting order and supplier info for products. I can traverse the graph. I can count, how many orders for each product, how many refunds for each product, and get the supplier info. And I can do all of that very, very quickly. And if I add more types, it's all very fast to sort of extend and add everything together. Extend the application, that is. So what I wanted to show you here is just some examples of what we can do. So I'm going to exit out. I have to do this through the terminal, and I apologize for that. But it will show you what the agent is doing as I'm going through, which is why I wanted to do it this way. So I can ask a question like, for example, I'll run this agent again. What are some good sweaters for spring? And I can say, don't give me anything too warm. And it will go through, and you can see it uses prompt text, which is our vector search. It will look for the sweaters, and then it will return that eventually. So that's just basic vector search, and it will give me recommendations based on vector search. You'll see here. I can also start asking questions about suppliers. So for example, like which suppliers have the highest number of returns, i.e. credit notes. And so this is traversing over our unstructured and structured sources. You see here it says analyze with a general question. And so it's invoking, and it couldn't do that. So let's try that one more time. What happened there, it looks like it ran into an issue with invoking the right client, and now it's not using the function that it's supposed to use. So what I'm going to say is I'm going to say use the general query. So what happened was it hit a bug there when it tried to hit OpenAI, I think, and for some reason it couldn't get through. So now it's not wanting to use the right function. But let's see if this will help it change its mind. Yes, and it did. And okay, cool. So that happens with agents sometimes. And it's very interesting because it tried to hit this function. And this is a cipher, text-to-cipher generation function. And it knew, because I gave it that same ontology, right, that it had to go to suppliers, get articles, and then get the credit nodes. And then it was able to return, okay, here are sort of my bad suppliers who have the highest number of returns. It stopped using it because it tried to hit an OpenAI endpoint. It couldn't get to it. Now it can. But I can ask also, and we'll see if this works, what down here, what are the top 3 products for supplier 116, which is this guy on top right here? And can you get those product codes and find other suppliers who have less returns for each product I can use instead? And so it goes for the supplier IDs. And then the top 3 most returned products for supplier 116 are those product codes. And then I have to remind it what are other suppliers for those product codes that have less returns. and then it will go hit that product code. So it just hits a different tool, different Cypher templates that I have available, and then it will find some. So it'll find, okay, so this is like a good example of where this supplier had a lot of returns for this product, and I could potentially substitute with this other supplier here, 1646, which has, a lower number of returns. So just a quick example. The last thing that I'll run, because we're running very, very short on time, is a customer segmentation analysis. So what's really cool is that you've heard about community summaries maybe. Because we have a graph database, I can actually run very flexible types of community algorithms on the fly. So I can say, can you run a customer segmentation analysis, which is like a community summary? It's going to use a similar logic. I've created a tool for it. And basically what this does is it looks at customer purchasing behavior and it clusters people based on their purchasing behavior in the graph. And then it will give me sort of this analysis right here, right, of like the number of customers inside of each segment. If I were to look at it inside of the code, it would be, where is it? Get product recommendations, run customer segmentation. It's right here. And basically it uses graph data science, which is one of our it's a library that allows us to run graph algorithms. And it uses Leiden to basically look at co-purchase relationships between different customers. So that's very interesting. But another thing that I can do, which is even more interesting, is I can say, well, what if I wanted to use AI to create like promotional campaigns by customer segment? So I've designed another prompt right here to say, basically, can you run a customer segmentation? But then after you do that, and it sort of went off already, but draft an email, basically look at what, basically take the, top biggest segment just so that we can focus on one. And then I'll go all the way to the top here. What I asked it to do was take the biggest segment, and then what it would do after that is look basically for the recommendation tool. And then once it uses the recommendation tool, it'll come down here and because basically what it's doing is it's using that peer group recommendation that we were looking at earlier. And then it finds, okay, well, based on purchasing patterns within inside of that segment, here are sort of the top products that I would recommend for that group. And then it could put together a campaign. So you can imagine the possibilities with this type of tool. Once you have a connected graph, you can start asking it putting together these workflows for fairly complicated things and really reducing that time and gaining productivity in putting these types of materials and reports together. So I know we're very short on time, so let me go back to my slides and we'll finish off with some resources. The code for running this is this customer graph agent. So we're moving stuff around in GitHub. So I'm creating a website for the code. So then you can go there and get to the code through that. We also have other generative AI resources like learning resources, Graph Academy on our landing page. And there was also a great blog written by Michael Hunger, which is one of our lead product folks, around just what is GraphRAG to sort of reiterate the different types of patterns and stuff. So with that, hopefully that was all clear. I know that was like a roller coaster with me going through the terminal, but I guess I'll open it up now for Q&A.
All right. Well, thank you, Zach, for such a great presentation. It looks like we do have some time for a few questions today. I wanted to remind the audience, if they'd like to submit a question, they can do so by typing it into the questions tab at the top of your screen. If we don't get to all the questions today, someone on the Neo4j team will reach out to you directly, or you can send an email to webinar@neo4j.com and we'll get you pointed in the right direction. So with that, we did have a few questions come in already, so let's get started with some of those. All right, this is a great first question. This individual is asking, what did you use for entity resolution when loading the credit note stuff?
Yeah, so that is a good question. So when you, and people who have done this before, these types of like NER, named entity recognition workflows, will know that when you ingest things from multiple documents, you sometimes get repeated entities. And then it's like, well, how do you like resolve those entities afterwards? So the GraphRAG Python package itself does some preliminary entity resolution inside of it. It's actually on by default. So that happens. And then we also have other functions which I use inside of that code. And I don't know if it's worth pulling up again now, but basically APOC, which is another plugin library that we have for our database, you have what's called a refactor merge nodes. So I can like go through the graph globally and scan for nodes with similar properties. And what I do in that example is I go by the IDs and I merge nodes together, and it maintains the relationships. So the relationships, like if you have two relationships at two different nodes and it merges to one node, that node will have the relationships from those two other nodes that it originated from. And the properties basically get put together inside of an array. So that's how it's handled right now. It's sort of a combination of the GraphRAG Python package and then also going through and using APOC after that, all with our own database tooling, or the, I guess, queries and tools for the database.
Great, thanks, Zach. All right, moving on. The next question, was there vector search in there? How did that work? If you could answer
so
this
one. I think we were short. Maybe I was like mistiming myself, but I thought I was running long. So what I didn't show you was how we created the text vectors. There's actually another step in there in my code where for the product descriptions, like every product, like, you know, whether it's jeans or a hoodie or whatever it is, has like a text description. And there's just a piece of my code that will use some native functions inside of Cypher to call OpenAI and just put like the text ADA, the default embeddings on those. And then it creates a vector index on top of that. So I apologize. I ran through that super quickly, but basically for like that product search, when it was using vectors, it was leveraging the vector index that I put inside of Neo4j in that instance. So every product node from the structured ingest has vector indices as well as the document chunks, but it was using the ones from the product nodes.
Awesome. Thanks for clearing that up. And then it looks like we have time for one more question. And this person's asking, where can I find the code?
Yeah, well, maybe it came in earlier, right here. So at that, it should be up by now. If it's not up, it'll be up in like a day. But basically, like I said, we're moving we have a lot of GitHub repositories, so we might be moving code between GitHub repositories. So I'm putting things on a web page, so that way it's a little bit easier to get to the web page. And then even if like the code like shifts repositories, you won't be like thrown off by that. So the web page has all the links to the code, the source code, all the stuff I was walking through.
All right. Well, thank you so much, Zach, for being with us today. And for those in the audience, thank you for joining us today as well. I wish you all a great day. Thanks so much.